We are on number 2, question stem, and we had D and E. So we just finished C. So we had this table, right? Remember, in the table given was velocity. Always pay attention to what they give you. This could be position, this could be velocity, this could be acceleration, and what they give you, determines what you do here. We had just done C, which is helpful to look at. They wanted us to find an approximation for V prime of 8, okay, and then explain your terms there. When we did V prime of 8, since 8 wasn't a number there in that list, we used the numbers on either side, basically doing average acceleration there, okay, by setting up our slope type formula. Now, D asks us to find average acceleration of the particle for 10 to 12 seconds, explaining what this number means in terms of the particle's velocity on the interval. So, how are we going to find average acceleration here? It says for 10 to 12 seconds. What do we notice in our table up there?
We set it up like a ratio, like f of 12 minus f of 10 number 12.
Basically that slope type formula, yeah. Okay, so average acceleration, that's the derivative of velocity. And so that is our slope type formula there, slope of the secant line, basically. So we're going to do velocity at 12 minus velocity of 10 over 12 minus 10. Or you can do 10 minus 12. It doesn't matter either way, as long as you're consistent top and bottom. So I personally tend to say V of 12 minus V of 10 over 12 minus 10. V of 12 is 3 minus V of 10 is 5 over 12 minus 10. Negative 2 over 2, which is negative 1 if I've done my math correctly. Negative 1 what?
Oh, it's feet per second.
Feet per second. Feet per second squared.
Oh, yeah.
Feet per second squared. Velocity is feet per second. So the derivative of velocity, or acceleration in any way, shape, or form, is feet per second squared. Okay? They asked us what this means in the terms of the particle's velocity. So if our average acceleration is negative 1 foot per second squared, what does that mean in velocity? Okay, yeah. The velocity, it means the velocity is decreasing on average at a rate of 1 foot per second or 1 foot per second squared. So velocity is decreasing on average at a rate of, you can say it as 1 foot per second, because that's another way to write foot per second squared is to say foot per second. So, or that is 1 foot per second squared. Okay? And E. Okay. Let A of t equal V prime of t, which we kind of already know. Acceleration is equal to the derivative of velocity. Is there a time t equals c guaranteed such that A of c, so the acceleration at c equals 0, in the interval from 0 to 15? Now, in the interval from 0 to 15, that just defines my whole chart, right? If you look up at your chart, that whole chart is 0 to 15. So in the time frame we know. And then justify your answer. Thoughts here?
Yes.
Why?
It is because it goes down from 10 to 12. The velocity goes down. That's right. Hey.
So we can actually use these last two answers if you think about it. So when we talk about is there a time when acceleration equals 0, that's also the same thing as saying is there a time when the derivative of velocity equals 0?
Yes,
Why yes?
because it's continuous.
Okay.
It goes from negative to positive, so at some point velocity will have to equal 0.
Okay. Go back to the original stem. Velocity is twice differentiable. Velocity is twice differentiable means that this is a continuous function, right? So because it's continuous, look at what happened here. Okay. Up here on 7 to 10, we had a positive acceleration. And then from 10 to 12, we had a negative acceleration. And if you look at that on the chart, we're looking right here, yes? From 7 to 10, it was, which way was it? Positive? And then from 10 to 12, it was negative, okay? So right there, it somewhere in that interval changes from positive to negative, and when you change something from positive to negative or negative to positive, that means it has to go through 0, and because it's continuous, we can state that, okay? So, one thing I do have stated in my notes is because V of t is differentiable on 0 to 15, A of t is continuous. Okay, so that is one thing officially we should state here. So because V of t is differentiable on 0 to 15, then we know that acceleration is continuous. And I mentioned acceleration is continuous because that's what we're talking about here, right? It's asking about does acceleration equal 0? If we go back to the two pieces we did on the last two problems, V of 10 minus V of 7 over 10 minus 7, that worked out to be 2/3, and we know 2/3 is greater than 0. And then the other one, V of 12 minus V of 10 over 12 minus 10, that worked out to be what? -1, which is less than 0. Okay, so those are the pieces you're using, okay, to put your, that's your supporting information. And then, so thus, acceleration will equal 0 somewhere on the interval from 7 to 12 because V prime of t changed from positive to negative. Okay, so let's say thus A of t will equal 0 on the interval. I'm just going to say 7 to 12 because that's where we know it happens, right? We know it happens 7 to 12 based on those two pieces. I do have seconds, I guess, here. And how do we know that? And that is because, and there's our proof over there, V prime of t changed from positive to negative. Okay. We had example 1 gave us an equation, so we were talking algebraic. Example 2 gave me a table. Example 3 gives me a graph when you're ready. So, pay attention to what the graph is. The graph at right is y equals v of t. So do note it is the velocity graph, right? Of an object moving on a line over the time interval 0 to 10. Assume that the positive direction is to the right. So that's positive would be to the right, negative would be to the left. Okay, so can't stress enough, v of t. On what interval of time is the object moving to the right? So when does an object move to the right?
Above the x-axis.
Huh?
What's above the x-axis?
Okay, because it's when
Velocity is positive.
velocity is positive, right? And velocity being positive in this particular graph, because it's a velocity graph, is above the x-axis, right? So when is that happening? 4 to 10. Okay, so moving to the right, so we're looking for when velocity is greater than 0. And that happens on the interval from, what did we say, 4 to 10? Yeah. 4 less than t less than 10. Okay, so v greater than 0 should be your information there, but if you need to write it off to the side, we're looking for when velocity is positive. Okay? When is the object speeding up?
Velocity, acceleration, and distance.
Okay, this goes back to speed. Increasing speed, same signs. Decreasing speed, opposite signs. So we are looking for when v of t and a of t have same signs. Okay, sorry, I'm always writing, how do we know this? Okay, so here, what are we looking for? We're looking for same signs. Thoughts on when they have the same signs?
4 to 6.
Okay. From 4 to 6, velocity is positive because it's above the x-axis, and acceleration is positive because it is increasing.
If acceleration is 0, would that be positive or negative?
It'd be neither. Yeah. So we know from what, 6 to 8, nothing can happen because we've got a 0 acceleration. From 8 to 10, I've got positive velocity but decreasing, so negative acceleration. 0 to 2 is not an option. Here we've got positive slope but negative values. Okay? So you guys agree there? So I'm going to say on 4 less than t less than 6. And my reasoning is since v of t is greater than 0, which that just means v of t is positive, and Amola says v prime of t is greater than 0, and that is increasing. Okay, see when you're ready? How fast is the object moving at time t equal 3 and in what direction?
Speed.
Well, speed can't be decreasing.
5. It's at
So-
negative
Slowing
velocity.
down.
It's the negative means it's moving left. So
And then
yeah.
speed is absolute value of the velocity.
We're looking at that point right there.
Yep.
Because what we're seeing there is we can see that the velocity at 3 is -5, yes? But when we talk how fast, what are we saying? We're talking about speed. And what is speed? Speed is the absolute value of velocity. And so the absolute value of that velocity is going to be 5. Okay? And then it is moving left since v of 3 was less than 0, or in other words, negative. Okay? So bottom of this page, I'm really going to need the graph, and the bottom of the page are on a different page. Oh well. You guys ready? So D asks us for the average velocity over the time interval 0 to 4 and 4 to 10. Show the computations that lead to your answer.
Would be the v of 4 minus. V of 4 minus v of 0. That would you find velocity. Oh wait, there's just gonna talk to myself.
7.5. Well, and
V of 4, 0.
for the first one,
I think it negative 10 over.
Almost. Sorry, I'm confusing myself, which is why I'm not talking for a moment. I'm letting you guys reason because I'm confused looking at my own notes here for a moment. Sorry, I have a piece not making sense on mine.
So
I
there's
can't.
2 answers, right? We need the average velocity between 0 and 4.
Yes, we need 2 average velocities. Now, I'm curious. Aiden, you said something about 7.5.
For 0 and 4,
And why did you say that?
because it makes sense.
Does it make sense?
I split up the first from 0 to 2, the average is just 10. From 2 to 4, the average is 5. Average of both of those would be 7.5, and negative 7.5.
Negative is the key. That when you said 7.5 earlier, I said almost. Okay. Yeah, I was struggling because, okay, here's the deal. To do average velocity, velocity is the derivative of position. Okay, so we need to do the change in position over the change in time. This is where I was having that moment because I was trying to do the change in velocity over the change in time, and it wasn't working for me. I was having a moment of not comprehending. So, but yeah, so we're doing change in position over change in time. And if you recall, when we start talking about distance in a velocity graph, okay, it's the idea of, and I think I have mine split up too. How did I do that? So from 0 to 4, I kind of have mine split up too, but this section right here, it's 2 by negative 10, so this is a 20. This over here is going to be half of 20, so this is negative 10. And that's how I put those together then. And said negative 20 and negative 10, that's going to be negative 30, and divided it by 4. Whereas you put your two averages together, didn't you? Okay. So because this is velocity graph, your area under the curve, okay, in this case it's below the axis, your area under the curve is your total distance traveled. Okay, and that's what we're looking at there. So, and then when we get to, what do we know about 4 to 10 when we get there?
So it's a little more difficult.
It's a little more difficult, I agree. I mean, it's one big trapezoid, or, is that better? This is 2 by 15, which is 30. And what about each of these triangles? I mean, they're half of 2 by 15, right? So half of 30, which is 15. Okay, so then you can look at the 15 plus 30 plus 15, 60, and it's over a time period of 6. So you can divide it that way. Okay. Okay, let me go down here and put some work here. So, one thing you do need to think here is a change in position over change in time. Okay, or I also have it as total distance divided by, elapsed time. Okay, so, and I did this, I broke it into the two pieces. On the interval from 0 to 4, okay, from 0 to 4, we already talked about it being what? Negative 20 plus negative 10, which is negative 30. That's going to be your total distance. And then in order to do the average velocity, you're dividing, right? So negative 30 divided by a time distance of 4, and that gives us the negative 7.5. The other piece was on the interval from 4 to 10. For the total distance there, I had it broken into 15 plus 30 plus 15, which is 60. In order to do the average velocity there, you're doing 60 divided by time frame of 6, which is 10. Do we not have labels here? I guess we don't have any labels, do we? Okay. So looking for answers of negative 7.5 and 10. Now, notice on D, they broke it up into positive and negative, yes? So the 0 to 4 was the negative. The 4 to 10 was the positives, right?
Yes. That's for Caitlin.
Okay. Oh, I thought the big box was coming in here too, but.
Let me see this week, so.
Okay.
I want shoes delivered to calculus.
Shoes or what?
We get new cheer shoes for basketball.
As I said, I want shoes delivered to calculus class, you know. Okay,
Okay, so it's just an illusion.
Oh, you're right.
E.
Feel better now.
This one is, what is the total distance traveled by the object? Show the computations that lead to your answer. Total distance.
Well,
We kind of just did it. Kind of.
a little bit. So velocity would be like, oh wait, no, it'd be speed. No, I don't know.
It'd be distance.
What did we talk about from 0 to 4?
What about
The distance.
distance travel?
How much did it travel?
7.5.
Well, no.
Oh,
Average
sorry.
velocity was 7.5.
It traveled
that's-
30.
Oh, travel, yeah.
30, and officially we have it
Negative.
as negative 30, yes?
Make it positive, right?
But-
Absolute value.
Yeah, we have to talk absolute value here because now that we're talking total distance, if you take negative 30 and put it with this next number, we're not getting total distance. We're talking displacement. Okay? So, and then what do we know about on 4 to 10? 60. Technically the absolute value of that, but you know, it's already positive. And so we have what? 90. And I have 90 units in my notes because we do not have a label in this problem. Okay, so either don't label it or use the word units. If they require a label, a lot of times you can get away without labels. If they are going to grade you for a label, I feel like it'll usually say, what's the label? You know, label it. But just general units. Okay. When is the object slowing down?
Between,
That's when the signs are opposite.
Okay.
The
When V of T and A of T have opposite signs, I agree with that statement.
it's 2 to 4 and 8 to 10.
Nice.
Do we agree?
Yeah.
That's what I have in my answer key. So, 2 to 4 and 8 to 10. On 2 to 4, my graph is below the x-axis, so velocity is negative, but it's an increasing graph, so the acceleration is positive. On 8 to 10, it's above the x-axis, so velocity is positive, but it's a decreasing graph, so acceleration is negative. Okay? When is the velocity increasing?
And
Huh.
I don't. Wait,
wait,
wait.
just kidding.
4 to 7.
No, she said 4 to 6, right?
I said 4 to 6, but
Oh, sorry. Okay. 4 to 7.
I agree with 4 to 6, but when else?
4, 2 to 4.
Why? Because it's just when it's
Because it increases? No, I don't
That
know.
don't make no sense.
4 to 6.
But it-
Velocity increasing. How do we know when velocity is increasing?
When it's
When what is happening?
accelerating.
When acceleration is positive. When is acceleration positive?
Oh. Why
When my
didn't they
slope
just-
is positive.
Why didn't they just ask when it was accelerating?
Acceleration. Isn't it slowing down now? Between 2 and 4.
But that's not what they asked. They didn't ask when is it slowing down. They asked
When velocities.
when velocity is increasing.
I give up.
So, okay. I just went the wrong way. Ah. Okay, we just did slowing down. Okay, there are two spots that are slowing down, and that's when velocity and acceleration have opposite signs. This is just when is the velocity is increasing. This doesn't have anything to do with speeding up or slowing down. This is just when is your velocity increasing. Velocity increases when acceleration is positive. And so when we're looking for acceleration to be positive, that's your velocity increasing. Or when is acceleration positive? That's when there is a positive slope, right? Because this was a velocity graph, than, come on, erase, positive slope. Okay, so Caitlin had it broken into pieces just as we were talking about it, but I have it listed as 2 to 6. Okay. Velocity increasing is when acceleration is positive. Acceleration is the slope of the line, so it's a positive slope. Okay, what about H? Does the object move at a constant speed?
So what is the slope? 0.
So when your acceleration is 0. And when is my acceleration 0?
Come on,
Zero
Augie.
to 2.
Augie has an answer. We should make Augie answer.
Shut up.
0 to 2 and?
Augie? What? 6 8.
I don't know.
Because he's been participating.
Yes, I have. You're just as muggly as you guys have.
Okay. Sample 4, make sure you have a calculator.
Nice.
You complain when you don't get to use a calculator.
Don't get it for him.
I'll get it for him.
Don't get it for him.
You need yours?
No, I have one.
He has his.
Wait. No, I'll just take that.
What?
Did Tate actually have his with his?
I think it's
Okay. Example 4. I don't know if we need a calculator for all these pieces, but we do a lot of them, I know. An object moves along the x-axis for time 0 to 6. The velocity of the object at time t is given by that fun formula,
Nope.
thus the calculators.
Not doing it.
Okay. 4. T equals 4. Is the object speeding up or slowing down?
I got it.
Wait, is this like a new, always still using the graph?
This is all about this fun formula, which is why you have your calculator in front of you. What do we have to figure out?
Natural log.
the derivative of the equation.
With the derivative.
Okay. We're not going to do the derivative here.
So we just plug it in.
Okay.
Everybody slow down.
Hold on.
Hold
What?
on a sec.
How do we know if something is speeding up or slowing down?
Oh,
The sign do the same.
The signs of.
Velocity and acceleration.
So basically, I need to know what the velocity is at time 4 and what the acceleration is at time 4. Fair enough?
I don't know which one this is, but I'll do it.
Now, they gave us V of t, yes?
Wait,
Now.
yes, they did.
Since we have to use this V of t several times,
Let's
could I
it
put
in
this
a Y.
into a y?
You could.
No, I'm not saying you have to, but could you?
Yes.
You could. I'm going to because that looks not fun.
Where is natural?
Natural log
There it
of x minus 0.15
is.
x to the third
Jake, where's natural log at?
plus
Left.
left side.
Up from 2.
Oh, there we go.
Yeah, there you go.
You guys are definitely going off the calculators too long.
Yeah, I forget all the buttons and tricks I know.
I never knew shit. It's like riding a bike.
Okay. Natural log of x minus 0.5 x to the third plus parentheses x squared plus 2x raised to the 4 divided by 5. Now, because I have pre-calc equations that I don't want to delete before next period, I put mine in y3. Yours is probably in y1, I'm guessing, right?
We.
Second quit is always a good way to get out of things.
Yes.
I just spam buttons.
How do I get it again?
Okay, now, first thing we need to know is the velocity at 4. What equation did I just type in?
Velocity.
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 So, if you go into your alpha, if you hit alpha, and I think it's F4,
Yeah, I think that's what I did.
there's y1. I'm going to go down because I need y3. And then you put parentheses, 4 parentheses.
Yes.
Okay, so my velocity at 4 is officially approximately 4.496, but all that I really care about is that it is positive. Now, what's the relationship I know about acceleration?
Derivative of velocity.
I can't even respond to that without laughing there. Okay, so
Derivative of velocity.
our calculator can do this, yes.
Yeah. Oh, how?
Your calculator can do the derivative if you are evaluating at a number. Are we evaluating at a number?
Yeah.
Yeah. Okay. Now,
Yeah.
there's 2 places.
Yeah.
First of all, I'll show you the long way, or the non-shortcut, because it's up in one of my like F3 menu, I think. It is here in math. It's number 8 in deriv. But what I prefer to use is alpha, I think F3. Nope. Alpha F2. Alpha F2, there's in deriv. And it pops up this thing.
Yeah.
It's ddx. Now, you can type in that fun equation, or
Why what?
No way.
you can use the y thing again.
I forget how to get there.
Wait, how do you do that? Alpha F4?
Alpha F4 is where you find your y,
Oh.
and you're evaluating at x equals 4.
That's beautiful.
Isn't it, though?
Yay. Negative. It's negative. Uh-oh. Hydrogen is slow down.
So, we found that the velocity at 4 is greater than 0, and the acceleration at 4 is less than 0, thus the object is slowing down at t equals 4. That was 100% easier with a calculator.
Yeah.
I don't know.
3.
Well, it was natural log. We couldn't have even done that without a calculator. Okay, B. At what time on the interval from 0 to 6 does the particle change directions? And justify.
Are we able to graph this?
Oh.
Graph.
The equation.
Yeah.
That's how we get.
So, at what time does the particle change directions? When does a particle change directions? When what equals what?
When b of t equals 0.
We want to know when the velocity equals 0. So, what should we look at?
When it crosses the x-axis.
We should look at the graph. So go to y equals. We've already got it plugged in, yes?
Oh. Does it twice. In. Got a problem.
Okay. Looks like it does it twice. I agree. So what's that first value?
I don't know. How do you tricks?
What trick are you trying to do?
The one where you put a point.
There's like
The x-intercept.
X-intercept. What's another name for the x-intercept?
Oh.
You're going to look for your second calc menu. So second and the trace button.
Find a 0.
Oh, I don't do that. Right.
You're going to find the 0,
Oh, there we go.
Left.
number 2. And then if we're trying to find that first one,
Alright, wait, where's my thing?
left bound, right bound, and a guess. Does yours match mine?
0.391.
Yes.
Nice.
Now, what is my particle doing there? It changes direction. What's it change?
It goes from left to right.
Okay, or the sign changes from negative to positive. Yes.
Yes.
So yeah. Actually. Am I done?
No. You must do it again.
Is there another value in this interval that looks important?
Yes.
Yeah. When else does my velocity equal 0?
5.007.
And what's happening at 5.007?
Positive to negative.
This time it changes from positive to negative. And the whole changing from positive, negative to positive, that's my justification. Okay. Officially, I guess it did say it moves along the x-axis, so we would be able to talk left versus right, but okay. Wow. Woo. Okay. Gotta move. We were doing well for so long. Okay, number 5. Particle moves along the x-axis so that any time when t is greater than 0, its velocity is given in meters per second by this fun function. What is the acceleration of the particle at t equals 4? What does this tell you about the direction of the particle? Oh, this is easy.
The derivative of the equation.
Okay.
Plug it for it.
So it's asking about the acceleration. The derivative of velocity is acceleration. So we're going to be looking at acceleration at 4. You know what you're doing here?
Let's try. Yeah.
Now this is the only thing we have to do here. So in all honesty, do I need to put it in a... I don't need to put this into a y equation because this is the only thing I have to do. You can if you want, but I can just go to like alpha f2, pick my inderiv, and just type my equation directly into there if you'd like.
How do I get the y there again?
Alpha f4?
4? Oh, wait.
Is that what you need to know?
Hang on. Let's see the integration.
Yeah.
Okay. Does your derivative velocity, or in other words, your acceleration, match mine?
Yes.
Okay. What is the acceleration of the particle at t equal 4? Found. What does this tell you about the direction of the particle?
Left.
Left. Okay. Particle is being pushed left at a rate of negative 1.89 meters per second squared is how I have mine written. Okay. Particle is being pushed left at a rate of negative 1.890 meters per second squared. And everyone got the answer right, aka everyone's calculators are in radians. Okay. Because if your calculator was in degrees, you probably didn't get that answer. Where am I at? Okay, I'm running out of time. I'm trying to look real quick. Might be quicker for us to do number 7 than it would 6. Did I have to find that derivative by hand? Okay, let's jump down to 7 for a moment. I don't know if regardless I have mine on the same screen. Let's look at 7. A particle moves along the x-axis, so at time t from 0 to 15, the velocity is given by that formula. This one's good. Okay. Find time t when the acceleration is 0.
So A of t equals 0.
Uh-huh. So we're looking for when a of t equals 0.
So, slope is 0.
So slope is 0. Mm-hmm.
So
So we're going to look for a graph.
Wait. Yeah.
A third root, there is a shortcut up in Alpha F4 or over in Math menu. Or Alpha F2, I mean, sorry. Alpha F2 number 6 gives you an X root. So we can do the cube root.
That's. Wait. Never.
Oh.
Well,
0.
I disagree. When are slopes going to be 0?
At minimum.
At min or a
Ah,
max.
crud.
Oh.
Okay. Slope is going to be 0 at a min or a max. Now, specifically, what interval are we on here? We're on the interval from 0 to 15. I'm going to go into my window here because I just want to look at my x values from 0 to 15. Remember how to change your window? And then I'm going to graph it. And so what are we going to have there? We're going to have, it looks like there is a max, right? Uh-huh. I have it as 2.151657. So the acceleration at 2.1516 is equal to 0. What does that mean at the velocity at that instant? If the acceleration is 0, the velocity does not change. Okay. B is kind of, I feel like we've done that one a lot today. What is the velocity and the acceleration? And then are you speeding up or slowing down? We just graphed that, didn't we?
Mm-hmm.
So that is Y4 on mine. I don't know what it is on yours, but so to do the velocity at 6, I can just do my Y and fill in 6. To do the acceleration, I have to do a derivative. Mm-hmm. See, you learned a lot on the calc there today.
Are we gonna need calculators for like all of them?
I don't know about all of homework, but probably part of homework.
Why is homework so long?
Okay, since they have opposite signs at t equals 6, the particle is slowing down. Okay. Are we okay if we skip 6?
Yeah.
Hopefully, there might be something that overlaps with it,
Wow.
but, okay. We've hit that magical out of time, so. Okay, guys. Homework due Monday. Is it 4 pages of homework? 5? I saw Randy the Roach.
What?
Randy the Roach.
The calculator man.
Don't remember Randy the Roach? He's back on number 9.
Or something like that.